Hello. I start speaking, and immediately the cars start with their louder engines than louder than what I want. Anyway, I don't want to start this over again. I have started a couple of times, and in the end, it will be the best I can do. I cannot offer anything beyond that. So, any technical glitches, I hope you will be able to bear with them. Anyway, hi. I'm very happy. I'm very happy to finally be here with you. I am sorry this is starting as a pre-recorded talk. I would like to deliver the whole talk at least in real time as it should be. But we have had so many problems finding the right time to where I can give this talk, and it's the meeting time for you. Well, that we decided the best thing is to pre-record it, and I will do my best to be available for question and answers at the end of the talk. And of course, I will give you my contact data in case you are interested in talking with me about anything related to this project or any other thing. Thank you very, very much. I'm mostly thankful to Evil Weasel. They have been very attentive to me, and they have insisted on me speaking to them, to you as a Chicago Python user group. And that's an honor to me. I cannot say I am an expert Python user by far. I can manage my way out of a shoebox or something like that. But well, yeah, I think I have a couple of things that may be interesting to share, and that's what I will try to do today. Um, Let me give you first a bit of background information as to why I am writing, why am I presenting this project. Uh, I work at a national university in Mexico, UNAM, and well, I have two roles there. One is the technical staff. I am the system administrator for our research institutes network. That's like the my main job, although it's the least challenging in a way. And I am also a teacher at the engineering faculty. I teach operating systems. And well, I try to get my students to become programmers. And well, that's not a very easy task. So most of my assignments are write a program that implements this thing that's also done in an operating system. Many things are just simulated, not even not much more than that. Like say write something that gives the user memory when they request a memory allocation, and have it back, or things like that are quite easy to get. In the end, an operating system is a collection of clever but simple tasks. But and well, I have done also some that are a bit less simple. For example, I have for several years already asked my students as one of the main projects to write something that could be seen as a file system driver for a completely made up file system that's unoptimal but easy to understand. So I give them, well, what's the structure of the directory of my UNAM FS, of the name of the university, FI UNAM FS, Facultad de Ingeniería, Universidad Nacional Autónoma de México, file system. And it's a file system that I change the specifications for every semester. So one semester it will be with clusters of 2 sectors. One semester will be clusters of 4 sectors, whatever I can come up with. And one of the things I want them to learn as a consequence of being developers, of being programmers, is that the user interface is also important. I am not saying that that I write beautiful user interfaces. No, when I write something, I'm usually more centered in the back end, and I try to make nice APIs, but I'm just a human. But well, happens that I am a teacher. So what I have told them is, well, you can write the typical prompt-based, menu-based program that they always write. But would you want to do that? So I gave them some extra points for better user interfaces. And for several years, I have suggested them to implement a FUSE-based file system. I will get to that very soon. A FUSE-based file system, in my opinion, would be the best possible interface for this synthetic file system I'm giving to them as an assignment. So I often get, say, graphical user interface things, but I have never so far in more or less, well, 2 semesters a year and maybe 5 or 7 years I've given this assignment, I haven't had a single FUSE-based a project yet. So I want to make, this semester I'm trying to make a change in that. What is this thing I wrote here, FUSE? FUSE comes from file systems in user space. It's a great kernel module. It's even been ported to other operating systems. I understand that there's something very similar to FUSE that can be used, well, on the BSDs and in Mac OS. I don't really know because I don't use them. But the thing is, I can code the logic for a file system in a high-level language like Python, and it will be presented as if it were handled by the kernel. Of course, what happens down there is that the kernel has an open API, and the kernel interfaces with libfuse that's in C, and there are bindings for libfuse where you can specify the different system calls to Python or to many other high-level languages. And it's fun. It's not particularly hard to write. I have found, well, it's far from trivial, but I want to share this project with you and get feedback from it. So, if you're interested in this project, you can fetch it now from my directory in GitLab. GitLab.com slash GunnarWolf slash FUSE in Python guide. So let me emphasize on I want to make this a hand-holding guide. I found several Python tutorials showing how to do this, but they're usually written in a quite terse style. I'm trying to cater for non-programmers that I want to turn into programmers. So what I'm attempting here doing is to, well, in order to say it's hand-holding, is to start from a very simple example and add features to it along the way. So I start by just writing an empty file system, then a read-only file system, then a read-write file system, then I'm going to using stat for managing file attributes, then a read-only pass-through, and maybe I will keep adding some steps to this. So well, here it's a bit more like explained, more specified. You will find in most FUSE implementations in the different languages several very similar to each other, several examples in the relevant directories. Say, for example, in Python we have, well, I'm running, of course, in Debian. There are many modules. I am using a FUSE that's closer to what we have in the upstream API. And here we have we have a hello file system, COOPS, IOC, I don't remember what this was, and XMP. These are not very easy to work with, except for hello that I used as a starting point. Yep, this one is quite easy. You can see it's very short, And what does hello do? Well, hello file system creates. Okay, how does FUSE look like? Here I am calling it. I just give it as its only argument the mount point, where it will be mounted. So this, as you can see, it's a directory I just created. Here I run the program, I get no output. But when I look at tmp-mnt, I have a hello file. And that's it. So what I want to teach the students here is what is needed to get this done. So I start, well, this is the example, this is not part of my code, but here you can see all of the, each of these methods that's defined inside the hello file system class that inherits from FUSE is a system call. Get attributes for a given file, read directory, open a file, and read the contents of a file. Yep. And well, this serves as an example, but it's not very good for hand holding. I think it was in Ruby we had more. I don't have it installed here. No, never mind. In some languages we have more and maybe even better documentation accompanying the modules. So, let's start looking at what I am doing here. And this way you can have the joy of looking at me as I explain. Yay! Okay, so these are my these are my 5 basic files. I am trying to take care. I don't know if I am really achieving it, but I'm trying to take care of following good practices and documenting things over a little bit over the top. I mean, documenting things so that students that know the basics of the language but are not used to developing anything beyond homework assignments can see how we are supposed to work when targeting larger projects, when targeting contributions to free software. So here you can see, for example, well, I have written doc strings explaining, well, what I'm doing. This is what I was just explaining. Here, let me start with the first one. Yeah. So here, what is this? This is an empty file system. I'll take this as a very first example. My basic file system is a file system that can be mounted and is empty. How can I do this in FUSE? Well, in order to represent an empty file system, I have to deliver the dot and dot dot directory entries, because otherwise it is not valid and my operating system will complain. Well, the programs I used to interacting. So for doing that, I need to implement only these 2 system calls, and they are very simple. Read there. Well, I don't care about the argument so far. Reader will only present 2 directory entries, one for dot and one for dot dot, and that's it. Of course, I haven't got into details on what yield really means, how it is used, but this is something that belongs to the FUSE API, not to this level of code. We only know we have to do this. Instead of returning the full list, we have to yield each one of them point by moment by moment. And here, if I don't give the attributes, it will look very ugly because the file system has no way of knowing the attributes it will be shown as. So what I say here is, as I am only handing back directories, yeah, in order to enter and read a directory, I have to use at least, well, I could use 0 octal 500 and make this available to only the root user or whatever. But I am choosing to give this that's read and execute to every possible user. And I am leaving all the details untouched. So we will now see the result of this. Well, yes, this is something that took me a bit of time to really process, to understand how it works, because the documentation for FUSE is not very clearly laid out. Even though in the readdir file system we give the file names rooted at this point inside the file system, here we will get the name of the directory, which makes sense after a bit, and I will explain this a bit later. So how does this work? Okay, here I am providing a bit of help, so let's see how MNT is empty, and if I run empty file system, well, I get the full help, which is a bit over what I want. Of course, this full help is given because I'm giving the FUSE options. Maybe I should remove them. I'm taking this from this usage, and I could make this much terser. But here what I have is empty file system, mount point, and options, if any. For example, here, without me getting involved in this, I could say, oh, and make the files for this and this user and group ID. Okay, so let's run it, specifying MNT. That's it, it's running. And if we look at the contents of MNT, I can see here the difference. Of course, my operating system is resolving this correctly, because dot dot points at the parent directory, which is a real in the real file system, but dot, which I've just created, is owned by root. It was created at the beginning of the Unix epoch, and it's in the directory mode I made available. Okay, here this shows that, well, I will get into this a bit later. This shows it works. It doesn't show much more, but on the other side, it's not very fun to run an empty file system, right? So my second step is read-only. And this one, well, in fact, I am reproducing this header everywhere because I started from the hello file that was written almost 20 years ago and is still distributed as part of the Python modules examples. Well, from here I started doing my own. But, well, here, this is a file system that will be kept completely in memory. So this is my file data. It's a dictionary where I have the file name and the content. Keep in mind that when we are dealing with files, as we have to give this to the operating system, we are dealing with bytes objects. We cannot use regular strings, or at least we have to convert our regular strings to via this conversion to a bytes object, because otherwise it will complain in a way that's quite opaque, that doesn't give us information. It just says that there was an input-output error. So this is worth pointing out and worth keeping in mind. Of course, I made this a comment for the students to know this. So I have here one file, here one second file, and well, let's see the difference. Well, I don't think it's yeah. There are many things that will make this a bit larger than it should, because I'm giving more the documentation and the comments. Yeah, but here we have a read-only file system. And for this file system, well, what I'm showing here is that most of what I'm doing is kept identical. I'm just adding support for reading a file. So well, let's go to the code itself, not to the diff, but you can see that I'm trying to make this gradual, to add things in a way that can be compared. So here we add the read call, as I said, syscall. Read there, well, now shows also the keys, that's the file names. Every item that's given by read there must be converted into a FUSE directory entry object. And well, here for the attributes, okay, we start adding a bit of complexity. The only two directories that can exist, this will be a flat file system without support for hierarchic directories. The directories have two links. That's each directory is linked to itself and from the parent. And for all other files, they will be a stat.ifreg. That's a regular file with read-only access, not read execute, but read-only for every user existing. And I am giving the right size, because when my programs read the file, they will not expect things to go over the size. So at first I thought, well, I can just invent the sizes and things will be fine. It doesn't work that well, and I'll get to that a bit later. Sorry. And well, of course, get attributes. It may happen that I get requested for the attributes that I don't for a file that doesn't exist. If so, I return no such entity. So reading a file could be easier, but I wanted to implement the real interface that we have in Unix. It could be easier because I could just ignore, and I've done it in other places, ignore the requested size and the file offset. This, of course, adds a bit of complexity, which I didn't want to put too much of, but I think it's important to show. So, well, we first find whether the file is a valid key in our file data dictionary. If not, we return no such entity. And here, this is what implements those two limits, the offset and the size, right? I just hand back the amount of bytes that was requested, and if it's as Unix does, if I'm being requested for an offset after the end of the file or something like that, I just return an empty string. And that's it. Let's see it, and let's also look at how to make this a little bit better. So Okay, it was unmounted already. Yay, I'm great. Okay. So again, you will now understand why I insist to my students that this would be the best possible interface for a file system they have to implement. Now, here there are many things that I sometimes want to debug. And well, the way that the FUSE module works in Python forks and gives back a control almost immediately. Well, immediately. I have found it very useful. To run this with -d that's in debug mode. So this doesn't yield anymore. This way, okay. Sorry, this doesn't go to background anymore. And here, I can see what's happening. So this is also interesting to give to students of this subject, right? What happens when you want to show a directory? Well, it's not only that it's reading the directory, but it's also getting the attributes of the root, reading the directory, then making a lookup for each of those files and getting the relevant attributes just to get the directory. Here, I'm not requesting anything beyond the file names, but what happens here is that when I list the contents of a directory, here I'm showing with different colors what's executable, what's a directory. That's well, the usual behavior for the GNU tools ls. A simple directory program would not require to get the attributes of to each of those files. Yeah, in this case, a file and second. But here, ls does query for those attributes, right? Okay. And yeah, and here, in order to finish this this program, I have to unmount it, and it returns, right? So the next step, I will try to be a bit faster now to not to give too many details. After all, I'm just going over the same. This is a read-write file system. So what do I have to add in order to implement read-write? This is a truncate and write. These are the two new system calls that I'm introducing. So let's look at them. I could have decided not to implement truncate, for example, but since I don't control what my shell or any other file are doing, I will be hit by unimplemented and that would be bad behavior. So this is what I have. Okay, read is the same, and truncate basically receives a path. I drop the leading slash. Okay, I'm getting the file size. Okay, right. Truncate, if called without any arguments, truncate just basically recreates a file, keeping its pre-existing attributes, or creates it anew, but we can also specify to which length we want to truncate it. So here we have to check whether truncate can also make a file grow. So, well, here I can either mark it as larger or just truncate it. Just like cut it. And write, well, of course, write takes a string of bytes to write and accepts an offset where it will start writing. And well, this I think will be basically obvious to mostly any of you. If the offset is greater to 0, well, write the new data starting at that offset. If it's beyond the end of the current okay, if it's inside the current length of the file, write it in place, and basically that's it, and return it. So again, I will do it as two different sorry. So far, yeah, so far it's what we have seen so far. Of course, I'll go back to keep this a bit more quiet, because my prompt is always looking for Git related things to give me here, and it creates a lot of extra system calls. So again, cat mnt.a file, and I have it here. So I have the get attributes, and here I have the read, where I'm reading up to 4K. Okay, so okay, and here where I modify this, I have a write. See, where yeah, when I'm writing 21 bytes to this file, or I can as I did here, I have a write of 21 bytes. I didn't have a, I would expect this to cause a truncate, but no, it was also a write. Okay. Of course, so far I haven't I haven't added anything that would modify the directory. So whatever I want to do that I don't have implemented so far, I will just get function not implemented errors. It's not that it doesn't have permissions, it's that we don't know how to do it. Okay. What else? For the fourth iteration in this set of steps, I added a, oh well, this is an extra class. My file system now has date handling. I started calling it with date handling, but it's really with basic stat information. So let me go up here. I added two classes, file stat and file data. Let's go first to file stat. This basically represents the basic stat structure that we get when we call when we ask for the information for any item in our directory. We get this structure. But I found it a bit easier, maybe to explain, to just copy this over and have it initialized, safe with the timestamps and my user and group ID, and have everything else set to 0. This was just for beautifying the things, right? And having the file stat, the file data is when this holds the full information for a given file. So when I want to work with a file, I will update its file data, and this will get it from the underlying object. So again, I'm doing very little here, but it will be enough for showing. And here I have this same 5 system calls I've seen so far. The main difference is that where's my definition of, maybe it's moved, yeah, it's down here. Well, my file data is the same. I'm sorry, I got lost a bit in the woods, but here I have, well, reading the directory is the same, but the attributes will now make sense, because I am getting the information from the file stat or from the relevant file name. Okay, yeah, I will have here the stat attribute for every file data. So, sorry, I almost forgot about this one so far. But you can see my file data now includes a stat object. And it has very little modifications regarding the previous one, but gives a better feeling of a real existing file system. So yeah, so this is now this reflects now the present time. I'm always initializing these files as they are absolutely synthetic. They're only in RAM, so I set them to the moment where this file system was instantiated. So this was at 13:28. I'm waiting for the clock to turn to the next minute. So it's still not turning, but I just wanted to show this, that here I'm getting the attributes, look up, getting the attributes. Touching, yeah, touching is not yet implemented. Okay, yeah, setting them like that is maybe not implemented, but okay. Yeah, but here you can see the metadata is also modified, not only the file data. Right? Well, I was going like gradually one after the other, but then my fifth one went like one step back. So from 1 to 3, 3 you can derive to 4 that implements this read-write with stat information, or you can go to 5 that implements read-write but doesn't care too much about the uh, the metadata. But here, what I wrote is also another common example. It's like a read-only pass-through file system. What's the issue? What's the interesting thing about this? Is that this is the first time that I take care of representing subdirectories. So you can see this one as it's only read-only. I went back to only 3 system calls. And well, here what I'm doing is to present a given existing file system in a read-only way. We could say it could be useful, I don't know, if you want to set up a very secure web server that's impossible to modify. Then you like bind mount like this, and it's impossible to be modified. Okay, whatever. What I want is to show the handling of directories. So well, here I was. I'm now using a source directory. That's yeah. When I initialize here, I hadn't shown this before. Where okay, at some point I had implemented this at arbitrary rooted at arbitrary directories. At some point, I remember something didn't work, so I'm forcing this to be over the current working directory. But I do plan on getting this back to a fully specifiable way. And well, here, where was it? Well, we will find things like this, that when I open a directory, I set the source directory plus whatever I have here in the path, and maybe it was not in this one. I will get to this in a following example. But well, this one, the pass-through file system, it's very simple to show. Yeah, here I have written this, but this doesn't. I think it's not working because we saw it was hardwired in the definition. But well, let's. Okay. Oh, again, when I enter, it gives too much noise here. But this is my base file system where I have this project. Yep. You can see, well, it has basically quite liberal permissions, but inside the mounted directory, everything it's read-only. I am keeping the representation of whatever was given here. For example, this is still created in memory, and of course here I will have like I can recurse into this directory and it will be transparent, but well, this is a file system that looks simple, that looks easy, and the student can start doing interesting things. For example, okay, here it didn't work because pass through. Okay, well, this failed maybe because lacking some missing mount point parameter, of course. Okay, so here I have the full file system of my server, of my computer, where I can start playing with things. And things will be represented well with the right users, and that even well, this is something I haven't checked, but let me see, because I think it can be interesting. What happens if I request the inodes? Okay, that's it. The inodes are assigned as it goes, because this is a file system that's ultimately based in symbolic, like file objects. So this number doesn't in any way represent what's underneath. So for example, here this is the real set of files, and of course the inode numbers are much larger. Here the inode numbers will be granted, will be assigned as they are found. There are ways to predictably univocally pre-assign them. Anyway, this is the first part, the incrementally adding functionality. But I also wanted to show what I termed, and I'm not sure if it's a real good term, but I can also use this as useful bits of code. Well, first, I made this separation because when I teach, I first talk about file system semantics and how we represent objects to the user, and then later I start talking about how things are represented towards the device. What are blocks? What are directories? And say I use a lot the FAT file system because it's a production file system that's even if it's very old, it's easy to understand in one or two classes, and it can be useful. So I wanted to present some useful bits of code, and I've been having a bit of fun thinking on what can I do with file systems. Yeah, some cool ideas that present a useful implementation of something non-obvious. So for example, the first one I did was to create a DNS file system. But what is okay, I have to install the DNS. I'm working on a different machine. Maybe it's easier to just okay. So DNS file system in MNT. Okay. And here I will have these directories. So in this file system I can perform DNS lookups by just looking at whatever I want to find and the kind of record I want. So what is the IP address for ChiPy.org? Right? What is the mail exchanger for if you want to write a mail to me? For Debian or for my personal domain? Yeah. So I think this is useful, and this can show some things again to my users. I don't mean to distribute this as a generally useful free software project, because I am sorry. Okay. I don't want to distribute this as a generally useful thing, because it's in the end too simple and not really generally useful. but I think it's fun to show the students how they can come up with interesting implementations. So here I'm using the DNS module, and well, I'll make this easy, quick to show. I'm hardwiring many things, and okay, the lookup is on here, but here if I read the if I read the directory, yeah, here they will all be empty. But of course, it doesn't mean I cannot. The read there is very simple, but when I get the attributes, or when I read from one of the created files of the requested files, well, they will be there if here if the query, that's the first part of the path, the query type is valid, and there's a valid request at the second part of the path, I will just return the lookup for that query. I have found a couple of ideas that I think can be fun to look at. For example, we have many projects that have a lot of markdown. So this project, for example, it has this README, and if I run here I will have this README, and it will be already compiled as MNT README HTML, right? This is exactly what I have here. This is or I can just do cat or echo so it's not that useful, but it's fun, and I think this can be useful to show how this kind of file systems can be adapted and used for interesting things. So I made two more here. I will just show them very easily. They are dirtier because I haven't had the time to really prettify them. For example, here you can see that I have an unzip file system, and I am running this convenience thing at every invocation of every method. I am sure this can be done in a better way. Yeah, what I'm doing here is to whenever I read the directory or read any of the files inside of it, I will check if the zip file that was given to me exists and is valid. So, but this I think can also is a good interface. It's something that can be useful, and it wasn't so hard to get right. It took me a bit of time, but again, I am not an expert Python developer, so I am sure that any of you can code this in a lazy afternoon. Of course, here I added, well, this option, and part of what I want to show here is that it's relatively easy to add options from the command line. So let's do -o zip file, and it was using Python zip, in MNT. Okay. Oh, right. There was a very weird bug here that I haven't found out why. This works only this way. What was? Oh. Right now, this one had a bug, and I will fix it and get it running again. So right now I have to do the ugliest thing. Okay, it should be dead by now. Oh, right. It was in another system, in another computer. Silly me. Okay, again. Sorry. So here I am at the same computer, and right. So yeah, I am finding this bug, but anyway. Right, this is inside my zip file, which I think is quite good if you have a big right, if you have a big zip file and want to retrieve a single file. And finally, oh right, this one is the last I have written. It was maybe this can be run in a single window. So on CommentFS, while I'm taking care to write, to document and to write comments for my code, I think that sometimes it makes things very large. So what I'm doing here is and I still want to remove the empty spaces, but this can give the students mainly a clearer view of what I'm doing. So here, if from here I also remove these sets of say like this. Well, this is a full FUSE implementation of the empty file system, or this would be right, the most complicated one I have, right? So I think this can, I hope this can really help students understand what I'm doing and get their feet wet into writing file system code. Well, basically that's it. I'm stopping my recording now, and I will. Well, I really hope I can be available to answer any comments or questions you have. This project has been fun to tackle, and well, again, I owe this project to Evil Weasel, as they have prompted me into presenting something for the Chicago Python user group, even though, well, I'm just what I am, and I'm very happy and thankful for this opportunity. So I'll cut now. sorry for my handwriting. That's the only one I got, and of course I could have typed this, but I will leave with this. If you want to write to me, I am gwolf@debian.org, and well, again, I think I will be answering your questions in case you have any very shortly. Thank you.